All right, guys, welcome back. This is kind of part two of the video recordings. So last time we talked about, what is energy. If you look on my screen, there's a website, right? U.S. Energy Information Administration. We talked about what is this energy form. This time we need to talk about units and calculators, right? Mainly the units, because now we kind of have an idea of the energy sources and where they come from and kinetic energy, potential energy. But now we gotta actually start putting numbers to this. We gotta say what is or how much energy does oil have? How much energy does natural gas have? How much energy am I putting in my car when I go fill up the gas tank, right? We have to put some type of measurement to this. And the way we do this is we have to compare different energy sources together to see which type can put out how much, or how much energy can we release from that, stored up gasoline or solar or the wind or so, right? And the way we do this is we have to look at units, right? So energy units have been around for a long time. It's just we have to quantify them with whatever source we're using with, right? So here it says we got physical units are measured distance, areas, volumes, heights, weight, mass, force, energy, right? We all learned that from physics, right? So when we talk about actually energy sources, look at oil. How do you measure oil, right? We either measure it by barrels of oil or gallons, right? When you go to the gas, you look at barrels of oils when you're looking at the, how is the economy doing, what is how's the stocks going, right? Barrels of $42 a barrel of oil would tell you something, right? Of course, when you go fill up your car, you're gonna be looking at like $3 per gallon of gasoline, right? So that's pretty common. Everybody knows that. Probably the not as common knowledge is natural gas, right? Depending on where you live or where your house is connected, you might have natural gas or not. For example, my apartment has natural gas, so we have a kind of natural gas meter outside. I get charged by PG&E for how much natural gas I use. So how do they charge us, right? They actually go by here cubic feet of natural gas. So they're going to measure how many cubic feet will go into your house and you use to heat your stove or the heater because it's cold outside, all that stuff, right? Then we go to coal. Coal is another big energy resource that we use, not so much in the house anymore, but for electric energy, right? And because coal is so rarely available and the energy density coal is not nearly as good as the other ones, you need a lot of coal to get energy out. And not to mention, it's kind of like a rock, right? So rocks are pretty heavy. So put all this together, we're going to have to measure not really by pounds of coal, but by tons of coal, right? And so that's kind of the standard we use is how many tons of coal does a power plant need to operate, for one day or so. And then, of course, you have a price tag. How much does 1 ton of coal cost, right? And then, of course, lastly is the electric energy, right? That's something that we know as power engineers is kilowatt hours, right? Look at your power bill, you get charged 12, 13, 15 cents per kilowatt hour, right? So typically in electrical systems, that's what we use. Now, the big question is, if I want to heat my house, what's the most economical way to do that? Do I use gasoline? Do I use natural gas? Do I use coal? Or do you use electricity? We don't know right now because we can't do any conversions. We can't compare any of them, right? And this is where units will come in, right? So here we're talking about, oh, look at that, comparing units or comparing energy, right? So it's really hard to compare a gallon of gas to a ton of coal, right? So what we need to do is we need to have some type of intermediate unit that can measure all different levels of the tons of coal, the cubic feet of gas, right? And this is called we use a British thermal unit, a BTU. If you ever had to go buy an air conditioner before, you probably have seen, how many tons of AC as a tonnage, how many tons is AC, or how many if it's a window unit, how many BTUs is produced, right? So a British thermal unit is just literally a unit of energy, right? And it's not tied to oil, gas, coal, or anything. It's kind of a neutral one. So that's a good comparison where we could say, we could convert how much energy does a barrel of gasoline have in BTUs. So we could convert it over to BTUs, and then we could convert how many tons of coal, 1 ton of coal, how much energy is that? We convert that to BTUs, and then we could compare the BTUs from a barrel versus the BTUs from a ton of coal, right? So here, United States, BTU is a measure of heat energy. It's most commonly used for comparing energy sources and fuels, right? So here's a kind of common conversion factors: is 1 barrel of gasoline, which is 42 gallons, is equal to 5.7 million BTUs, right? And then a single gallon is 120,000 BTUs. You got diesel, heating oil, and so on, right? So just by here, we can see 1 gallon gasoline has so many BTUs. 1 gallon diesel fuel has a little bit more fuel BTUs. So that means for 1 gallon of liquid, diesel fuel actually has more energy stored in it than gasoline. And then heating oil has slightly more than diesel and more than gasoline, right? You got a cubic foot of natural gas is 1,000 BTUs. 1 gallon of propane is 91,000 BTUs. 1 ton of coal, which is a short ton, is 2,000 pounds. That's 19 million BTUs, right? So you can see over here, 1 barrel of gasoline is 5.7. A short ton of coal is 19. So almost 4 barrels of oil is equivalent to 1 ton of coal. If you're looking at kind of pure, how much energy is there to be released, right? And of course, what we know is 1 kilowatt hour of electricity is 3.4 BTUs. Okay. So, what about this whole converting part? That's what we're talking about, right? Let's look at some examples of converting different energy sources. So right here it says you have a natural gas furnace in your home, right? You use 81.3 thousand cubic feet of natural gas for an entire winter. And then your neighbor has another furnace that burns heating oil that uses 584 gallons. And you're kind of having to talk about, which one's more efficient, which one's cheaper, which one costs less. Because at the end of the day, you always want to use a cheaper option, right? So how do we compare this? We have to convert both of these to BTUs, because you can't directly compare the cubic feet gas versus the gallon, right? We don't know which one's good and which one's bad yet. So here, the basic conversion is you have your natural gas at 83,300 cubic feet of gas we used, right? And then we convert it to 1,037 BTU per cubic foot of gas. So here in the end, we have 84 million BTUs is how much we use. Then your neighbor says, well, I used 584 gallons. Well, we know up here, 1 heating oil gallon is 138,500 BTUs per gallon. Convert that over by multiplying, and you have 80 million BTUs. So if you see for over the winter, the natural gas, I use 84 million BTUs. He used 80, right? So he used less BTUs than I did for the winter, right? Even though, he used oil, natural gas before, we couldn't tell who actually used more energy. But now, because we converted to BTUs, it's pretty obvious that, I used more energy than he did for heating in the house. All right. Another example here is you need a new furnace in your home. Right now, you want to compare heating systems. Which one's a cheaper alternative, right? So here, I know, I could call up the utility and ask them how much does this energy cost, right? So here for I have 2 options. I have natural gas and I have heating oil. Right here it says you can compare the prices of fuels on an equal basis by dividing the price per unit, right? Meaning, for every 1,000 cubic feet I want to use, I'm going to spend $10.40, right? For every heating oil gallon I use, I'm going to spend 2.7 gallons, right? So per 1,000 cubic feet, how many BTUs is that? Well, normally 1 cubic feet is 1,037, but we're going by 1,000, so we got to multiply that out, right? And remember, 1,000 cubic feet, not 1,000 more cubic feet. It's cube, so we got to go 1,000 times 1,000, right? So here we're gonna have. Oh no, I goofed up. I'll take that back. My bad. So we have a cubic feet is 1,037 BTUs, right? The 1,000 is already taken out. So 1,000 cubic feet is literally taking 1,037, multiply another 1,000, meaning we're just putting 3 more zeros behind it, and so we're calling it a million. My apologies. All right. So we're gonna have a million BTUs per 1,000 cubic feet. So you divide by the price, and then we can see it's $10 per 1 million BTUs. So that's our efficiency for this natural gas, meaning each BTU I'm going to use, I'm going to be spending $10, right? So and so let's say I use 84 million BTUs, I'm going to be spending 84 times 10, $840 to heat my house over the winter, right? Looking at heating oil, we could do the same calculations of $2.7 per gallon. You divide by 0.1385 million BTUs. I mean, really, literally, we got it up here. 1 gallon heating oil is 138,000 BTUs. We're just throwing the decimal place over to get a million, right? And so you do the calculations here, it's $19 per million BTU. So you can see here, heating oil is actually twice as expensive to use to heat my house than natural gas. So what would I use? Obviously, I should use natural gas, right? But without this BTU conversion, when you're just looking at the price, well, $10 per 1,000 cubic feet versus $2.70 per gallon, isn't $2.70 cheaper than $10? Well, yeah. But again, you're not taking into account this efficiency factor right here. How much BTUs is stored within this unit that we're looking at, right? So that's why this conversion is really handy to use BTUs, okay? So that's that for BTUs. So we've been talking about so much, we actually got to ask, well, what actually is it? What's kind of the history behind it, right? So British thermal unit obviously came from Britain, and it's defined originally by taking, I think, 1 pound of liquid water and raising it up 1 degree Fahrenheit, right? Now, to be honest, that's not that much energy, right? It's actually very little, so it's kind of not a good base to use, but I guess because that's the only thing we really had, we had to keep going with it. That's why you always hear everything in millions of BTUs, thousands of BTUs. You never hear 0.1 BTUs, right? That's almost insignificant. Unfortunately, this is kind of what we're stuck with, so we got to keep on going with it, right? So that's why you say, yeah, a single BTU is insignificant in terms of amount of energy every single household. So that's why you always get quadrillion, million, and all that stuff, right? That's pretty much it. I mean, we're just kind of going over again all the different energy sources, kilowatt hour versus BTU, and so on, right? Gasoline, 1 gallon, diesel fuel, propane, 1 gallon, so on. And then we have wood. 1 quart is equal to 20 million BTUs, right? So I don't know if you guys are familiar with what 1 quart is. 1 quart is literally just like a big stack of wood, and I want to say it's I think it's 4 feet high, 4 feet wide, and 8 foot long. We got Google for a reason, right? 1 quart of wood. Let's look it up. Right. So yeah, these things right here. Let's go to images. So this is what 1 quart of wood looks like. God knows where cord came from. It's probably just some lumberjack who decided to say it, and let's just use that. So he kind of stuck with it, right? Here you go. That's a quarter cord. We're not looking for that. Here we go. So this is half a cord, 1 fireplace cord, and so on. So here it's 16 deep, 3 high, 11 long. So there's some volume level to that. Here's another version of it. This is okay. This is one I know. 4 foot high, 4 foot wide, 8 foot long. That's one cord. So typically use it when you go buy a firehouse, right? And to give you an idea, this truckload is probably equal to one cord. Okay. So just information for you. Good to know. Right. Degree days. I never heard this before. So I'm just gonna go ahead and skip it. Let's see what it is. Degree days are measured to see how cold warm location is. Yeah, we don't really need that. Maybe in a renewable energy side we might use that, so we might come to that, but for now I think we're okay. Right. Other things to talk about here, where do we use it, right? Where do we use energy and BTUs and all that stuff, right? So we're going to talk predominantly for the U.S. is we use many types of energy sets, petroleum, natural gas, coal, and so on. We already saw this graph before, just to show you how much consumption we have, right? And this is actually a really good graph over here. This shows the different types of sources we have and where do they go to what sectors of consumption. So you see we have transportation right here, right? So petroleum, natural gas, and renewable energy all go to transportation, right? And you can see a different percentage. So here, 92% of transportation is from petroleum, 3% is from natural gas, and 5% is renewable. You can notice how much transportation goes from coal? 0, right? Because we don't use steam engines anymore, right? And then of course 0 comes from nuclear electric power because we don't. It's not fallout. We don't have nuclear driven vehicles, right? That's kind of just fantasy land. Right? Then and transportation not only includes like cars on the road and tractor trailers and 18-wheelers. It probably also includes ships and airplane as well, right? Industrial, this is pretty much manufacturing processes, making all that junk that you buy on Amazon, making all your plastics and cars and all that stuff, right? 38% petroleum, 45% natural gas, and 6% coal, 11% renewable, right? Residential and commercial, this is pretty much the houses we live in. Commercial means like McDonald's, Starbucks, Walmart, basically not refineries, not processing plants. That's what commercial is, right? You might put in hospitals and police stations under municipals into commercial. I'm not really sure where that goes, but I would probably say it goes under commercial, right? And then lastly, of course, you have electric power, right? That means, generation to make electricity for the whole United States. And so as you can see, electric power is by far the biggest. One thing that actually surprised me a lot is transportation is really big too, if you really think about it, right? I guess, we have a lot of cars. We don't really have trains. And we walk. There's only very few cities that you can survive without a car. So go figure. In America, we spend a lot of energy on transportation, right? Let's see. Yeah, again, this is kind of retelling the same story in bar graph form. Energy production by sources. Again, natural gas, crude oil, coal. Those are the main players. Nuclear's a little bit. Right, this is another type of natural gas, and then you got all your other biomass, hydro, and renewables down here. Yeah, I think that's pretty much about for the stats. Here, this is actually pretty interesting. Is you could go and actually select by state a map, and then it'll show you all the electrical sources or all the energy sources. Right, so here we could go to Sacramento, and we could see that, here, at the top of Midtown, kind of by the river, we have a solar power plant of 1.5 megawatts. Right, downtown probably is like a backup generator. We're going to have a natural gas plant. This is going to be 2.9 megawatts, and so these are really tiny. Right, we could zoom out, go up here. Now this looks familiar. Folsom Lake. This is a Folsom Dam. All right, click that. Oops. What does this say? Folsom Dam. Right, hydroelectric power plant. 215 megawatts. So that's a lot bigger. It's not a giant dam, but 250 megawatts is not something to laugh about, right? So, and it's just pretty interesting. You know, if you're ever curious about, you know, how many dams do we have? Apparently, we got a lot of dams up north of Folsom, right? Up here is probably Oroville, I think. Yeah, Oroville Dam. This is a big one right here. You know, this is a 731 megawatt plant. And I think if we want to go west a little bit, San Francisco's around here. You got all your wind farms right here. So, you know, if you're curious of what all electric sources look like around us, that's what this map is for. It's pretty cool. Check out. Okay, we're going to go back. Uses of energy. Yeah, we already did all this. I don't want to talk about environmental just yet. So that's probably for later on. Now we're gonna get to non-renewable sources. So I'm probably gonna, you know, just cut the video off right here to get a stopping point, and we're gonna pick back up probably in non-renewable sources. Okay, so you guys hang on.